Hello there. Today we're solving a problem from Aluffi's Algebra Chapter 0. It is problem 1.2. So here we have our condition. This is an equivalence relation on S. And we have to prove that the family P is defined is a partition of S, and we'll talk about how it's defined in the book. So this family is actually equal to the set of the equivalence classes of the elements of S for some A, B members of S. So we can see that to prove that it is a partition of S, we need to prove three parts. Firstly, that its elements, which are the equivalence classes, are non-empty, and that it is joint and their union is S. So first we want to prove that they're non-empty. So I think we may safely assume that the question means that, S is non-empty itself. Otherwise, it wouldn't have any equivalence classes, and you can't really say if they're empty or not. So since S is not empty, we have there exists some X in S, and which means that there exists some equivalence class of X such that this equivalence class is a member of the family. So since we're talking about arbitrary element of this set S, we're also talking about an arbitrary element of the family P. So we know that X is a member of this equivalence class, which means that this is not the empty set. And here we prove that it is elements of this family is non-empty. Right. And now we need to prove that the elements of P are disjoint. So suppose X is a member of S. So similarly, there exists this equivalence class. And we suppose that there's another element, Y, member of S, such that X is not equal to Y, and that X is not equivalent to Y. So there exists some equivalence class of Y that is not equal to equivalence class of X that is a member of the family. So suppose that there is some element Z member of S, and that Y is equivalent to Z. We know that Z is a member of the equivalence class of Y. So here we have X is not equivalent to Y, which is equivalent to Z, which means that X is not equivalent to Z, which means that Z is not in the equivalence class containing X. Since our choices of X and Y and Z are arbitrary, we may have that X, Y members of this are, let's just say that they are the intersection is the empty set, which means that the intersection of all elements of the family P is also equal to the empty set, which means that it's disjoint, which means that elements of the family are disjoint. Great. So now we'll move on to the last part, which is to prove that their union is actually equal to S. So here we suppose again that X is a member of S, blah blah blah. Something like this. Right. So we then have X as a member of the union of all the sets, all the members of the family P. Now we suppose that X is not a member of S. Then there does not exist any Y that is a member of S such that X is similar to Y, equivalent to Y. Which means that X is not a member of any of the equivalence classes, and therefore X is not a member of the union of all the sets in the family, which means that, well, combining the above, we may have that the family is indeed equal to S, and we're done.